And in fact, in your book, they actually derive this. They actually derive the force in terms of collision. They just make a little box. And it took me like a half hour to do on the board when I used to do it. And I don't do that because it's time we don't have, okay? But if you look in your textbook, they actually derive the ideal gas law from momentum and things that we understand. So this is a very cool thing, okay? Now, look at the V on the bottom. What is the V? That's volume. If I make this box bigger, the force gets less. Why is that? Why does more space to move around in result in less pressure? Fewer collisions with the wall. Why? Farther for them to move, and takes longer for them to get. I think that's the same thing, right? And then it's more spread out. There's more places for it to hit, so it's more spread out, right? Okay. So that's the relationship. I'm going to move this out of the way so we can construct our cubic meter here. I know. It's coming. All right. There we go. It's Puvnert, and I'm not going to show you the video because I did not have you sign the release to watch the video.
What's the release?
I'm just kidding. Have you guys seen the Puvnert video? I find that disturbing. The guy, like, yeah, anyway. Yeah.
No, what is it?
No.
What is it?
No, it's disturbing. Who has seen the Puvnert video? Yeah. It's the look on his face, I think, that really gets to me. He's like,
Messed up.
yeah. All right. Okay, so let's write this up here. PV. Okay. Concept 0, what these things are. Well, this is pressure. Okay, this guy is volume, right? This is moles. This is, why that one's 8.31 with these units that we're going to use, right? Okay, joules per Kelvin, right? And that is temperature. Okay. Now, here's the deal with this, okay? This pressure must be pascals, and it must be absolute. Gauge pressure makes no sense. I could have 0 gauge pressure. That doesn't mean I have 0 moles of stuff. Isn't that right? 0 gauge pressure just means it's an atmosphere. Yeah? A mole takes about this much at an atmosphere in 0 Celsius, right? It's like 22.4 liters. It's a box this big. My chemistry teacher had one. Okay? So it's got to be absolute pressure. It can't be gauge pressure. It's got to be pascals. So this is the game I play. On the ideal gas law sheet, if you look, the first things I give you are absolute pressure in pascals, but later on, I'm giving it to you in torr or something like that, and it's gauge pressure, yeah? Holy cow, you've got to convert it, right? That's the game. I mean, that's the only thing that's hard about these things, right? Volume is crazy. In chemistry class, I think you guys use liters, yes? Okay, but for great big physicists, right, a liter is just 2 liter for us, right? Okay, and so we use cubic meters, and there are 1,000 liters to a cubic meter. So they really are just 2 liter. I know, no laughing. They're just liter bitty units. Tough crowd today. I know. Okay. Now, a cubic meter is giant. A cubic meter is so giant that, well, to tell you how giant it is, we're going to build a cubic meter. All right. How many meter sticks am I going to need to hand out?
18.
4, 5,
6, 12.
6. I think we need 12, don't we? I've handed out 6.
12. I don't want that one.
How many do we have now? Do we need? Here we go. All right. Now, when Mickey's hand gets to the 9, they're going to spring to the front of the room and demonstrate and hold a cubic meter for us. Okay? 10 seconds. We got 1, 2, 3, 4, 5, 6. Oh, we got too many.
You handed out 1. They already told him 1.
Okay. Go! Dun da 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 Bum, ba-da-dum, ba-na-na-na, dun, da-da-dun, da-na-na-na, da-da-da-da-da. All right, quite there yet, and keep going. Come on, come on, come on, come on, come on, and call it. How much time was that? I can't even see because there was.
6 seconds.
20 seconds.
That was 20 seconds. Let's give him a big. No, hold it, hold it, hold it, hold it. Hold the cubic meter. Get back here, Ray. Ray. All right. Now that cubic meter is 1,000 liters. That's 500 2-liter bottles of soda pop. Yes, to fill that thing up. Get you back. Okay. If we fill that with water, it would have a mass of 1,000 kilograms. That's a metric ton. That's as much as a Ford Pinto with a 200 kilogram, 200 pound rider in there. All right, give a big round of applause for these guys. Leave the meter sticks up here, please. He's headed back to his seat. Whack. There we go. All right, the cubic meter. When they talk about standard temperature and pressure is 0 Celsius, or 273.15 kelvins, and 1 atmosphere. We know that, don't we? Yeah, we know that. Okay. Now, what about moles? What is moles? No, not Avogadro's number. What's moles? How do we figure out moles from grams? That's the key. What do we do? Divide by molar mass. So moles are grams over molar mass. Now, molar mass is a funny thing. Sometimes if it's helium, it's just the mass of the atom, because helium only just helium. That's all it is. It's 4.0026 or something like that, right? Okay. But sometimes it's complicated. If it's carbon dioxide, well, that's 1 carbon and 2 oxygen. Look up carbon, look up oxygen, double oxygen. Yeah? That's not so bad, is it? But sometimes they don't give you the formula, but there is a formula. Do you remember those? Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, hydrogen. You remember those? Yeah. Here's how you remember them. You must forget the mnemonic device you learned and remember this one. Okay? It is none of Fred's clients bring iron hats. None of Fred's clients bring iron hats. That's the way to remember them, because it's got clients and bring. Yeah, CL and BR. None of the other ones have that extra letter. That's what makes it the best. Okay, these are all diatomic, so just don't forget that if you have, so many moles of nitrogen, that it comes in twos, right? So the mass isn't 14.007, it's twice that, right? Yeah? Okay. And then what about temperature? Can I use Celsius? Why can't I use Celsius? I love Celsius. It sounds like a metric unit. Why can't I use that?
We don't like it.
Here, just wrap your mind around this, okay? Wrap your mind around this. If I increase the temperature from 1 degree Celsius to 2 degrees Celsius, do I double the pressure? Do I double the amount of moles or something like that? Did I double the pressure when I did that? Is that a doubling of the kinetic energy?
Yes. Yeah.
No, in fact, it is not, right? It is a change from 274 to 275. It's an incremental, a very small change. How about, let's put it this way. This will point it out, right? How about if I go from 0 Celsius to 1 Celsius? Is that an infinite change in energy?
No.
No, it is not an infinite change, right? Okay, so, yeah. You have to use kelvins. It must, in fact, here we go, right? Okay, this must be kelvins. It 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 must be kelvins. Now, for my part, I will continue to give you Celsius all year long. I'm going to cast that baby out there. Did I get one? Yeah. Reel them in. Cast one out there. Get another one? Yeah. Okay? Yeah. I'm going to catch people all year long with that, and that's my job. Your job is to never use Celsius. It must be kelvins. Now, for the ideal gas law. It doesn't matter so much for MCAT, MC delta T, because isn't delta T like